Hello and welcome to Bright Sparks Electrical Training. This is part 2 of the basic electrics video, and if you haven't watched part 1 it might be an idea. In that video we explain voltage, current and resistance and also power and how to calculate those components. This video really just ties them together with an analogy that I like to use in my lessons. So by all means, if you think you know voltage, current, resistance and power and how to calculate them, carry on with this video. If you'd like a recap, go back to that video. The link is in the corner. And I'll begin with this analogy. So it's something I like to use in my lessons. And what we've got here is the World Surfing Championships, and it's in 2020, and of course if it really was a real life event then it probably wouldn't be going ahead in 2020 because of the dreaded coronavirus, but in this fictional event the World Surfing Championships are going ahead, and this year they're being held in Bikini Beach, which is a figment of every man's imagination. And as you can see, Bikini Beach is there, the sun is shining, the waves are flowing, and that's Bikini Beach there, and there's a palm tree and there's the spectators. And the great thing about Bikini Beach is that it gets big waves, and if we add another component to this drawing, as you can see, the wave itself is the voltage, it's the pressure. The bigger the wave, the bigger the force there is to take any surfers back to the beach. And that obviously leaves us now to add in the surfers. Now this surfer in particular is the French champion. He's the two-time world champion and he's going for his third world championships in a row, and his name is Ampere, the French champion, and he's the person that the crowd have all come to see. And Ampere now appears and he selects his wave, and he knows because of his experience that this wave is going to be enough to take him all the way back to the beach. The wave is pushing Ampere and Ampere is the current. Now, not explained in the previous part 1 video, but all current wants to do is get back to Earth, which I've drawn here as the beach itself. And I've written the words star point and then in brackets Earth. Don't worry about star point so much for now, but every property in the UK is connected to a star transformer, unless they're fed with their own generator, of course, but houses and offices and factories, etc., will be connected to a star point transformer, which is going to be explained in another video. And the middle of the star point is Earth. There is a huge rod that goes into the ground, and that goes straight into Earth. And all current, all Ampere wants to do is find a wave big enough to push him all the way back to the beach so he can melt into the sand. That is all current wants to do. Get back to Earth, where it then just disappears. That's its job in life. Now the organisers of the World Surfing Championships understand that, and in order to entertain the crowds as much as possible, they introduce ramps. Now this isn't a dodgy looking shark, that's going to come in a minute, I promise. They know that these surfers are lazy little blighters, and if they're left unattended they will just find a big enough wave to push them all the way to the beach, where they will disappear into the sand. Instead, the organisers want the crowd there to be organised, and they say to the surfers, okay, we're going to pick a location with waves big enough to take you back to the beach. In fact, with waves big enough to deal with the resistance of the water, because water will provide resistance against it. If that wave suddenly disappeared, Ampere and his friends would just sink into the water. So they say to him, look, we're going to provide you with waves big enough to get back to the beach so you can beat the resistance, And we also want you to do something in return for us, which is do a trick. We want to entertain these crowds. So we're going to provide a ramp for you to go over and do a trick, and then you can land and go back to the beach. And this ramp is the load. Now, as I explained in part 1, there's no point in having electricity if we're not going to make it work for us. We can't have a lighting circuit. There's no point in having a lighting circuit if we're not going to have lights come for it, or a heating circuit if we don't get heat come from it. So we need loads attached. We need the electricity to do some work for us. And that comes in the form of connecting a load. So Ampere is going to find a big enough wave, enough to push him all the way along, enough to push him over the load, because if the wave isn't big enough, Ampere won't go over. That's another thing to think about. This light bulb here won't turn on if there isn't enough voltage to push the current through it. He also needs to find a wave big enough not only to get him over the load, but to get him all the way back to the beach to counteract this resistance of the sea itself. But there's one thing that the organisers of the World Surfing Championships are aware of. They are aware of a shark problem. Now, this is my terrible drawing of a shark. Please forgive me for this. It's a cross between a shark, a dolphin, and a submarine in a James Bond film. However, under the sea, these strange sea creatures are floating around, and they know that something is going on. They know that there are surfers around and that they are waiting to nab them out of the water. These are faults, electrical faults. Let's have a think about them as that. Now, in an ideal world, these don't exist. Ampere will just surf along, do his trick, land, the crowd will go wild, he gets to the earth, disappears, everyone's happy. And that's how most electrical circuits operate 99.9% of the time. But occasionally a fault occurs, and that can be in any way, shape or form. And there is going to be a video about faults and different faults, so please check the channel for that. But when there is a fault, it is the organiser's job, or the electrician's job. Let's start thinking about this analogy as an electrical analogy. It's the electrician's job to recognise this fault, recognise what type of fault it is, and provide a measure to stop any danger happening. So this is a slightly better drawing of a helicopter than there was of a shark. But the organisers at the World Surfing Championships are aware of this shark problem, and they've got helicopters floating around above the sea with spotters on there, and they're looking for dark objects in the sea, and as soon as they spot something that looks like a shark, helicopters come down and drop a barrier in the water to prevent the voltage and the current from carrying on through. So Ampere and the wave are both stopped at this barrier, and the shark doesn't get his lunch. And that's exactly what we do. We provide a protective device, or a fuse in a circuit. So a plug top fuse, or the fuses that you have in your fuse board. We provide the correct type of fuse to deal with the right type of fault, the right amount of current, in order to stop the flow of voltage and current and eliminating any danger that may come of the fault. And that really is an analogy that explains exactly what current and voltage and resistance are doing in a circuit and how we can protect against it. So please watch part 1 if you haven't. If you have and you enjoyed part 1 and you've enjoyed part 2, please like it and subscribe to the channel. I'll be very, very grateful. Please share to your friends. Hopefully, if you have any questions, please just comment below. I will always endeavour to answer as soon as I can. And good luck with any of your courses that you're doing. And please keep your eyes peeled for more videos. Thanks for watching, and see you again next time.